Section 1.3 Trigonometric Functions. The first thing is you definitely want to know your trig values using unit circle to review them and memorize them. That will really help you in a long way. Now, so we start with evaluating trig functions. So tangent of 19 pi over 4 or 19 over 4 pi equal to 10. Now you need to think about how many rotation this is. Every complete rotation or every complete um, circle, right, on a unit circle is 2 pi. So if you look at this, it's how many a over 4 pi can we fit into 19 over 4 pi, and then we can fit into there nicely with two complete rotation and with the leftover 3 over 4 pi. So tangent 19 over 4 pi is the same as tangent 3 over 4 pi, which is negative 1. Now the second example is secant pi over 6. Now we know secant is 1 over cosine. So 1 over cosine pi over 6 is 1 over radical 3 over 2. So it's 1 over. So the answer is going to be 2 radical 3. Make sure we rationalize our answers. So the answer is 2 radical 3 over 3. Now the second example is we're going to be able to find all 6 trig values of a right triangle. Okay, we want to find angle A. So 6 trig values of angle A. So these are the eventually that's our ending product, right? So the first thing we're going to do is it's a right triangle, so we need to use our Pythagorean theorem. So Pythagorean theorem says a squared plus b squared equals c squared. And since we're giving a and c, we need to find b. So b must equal to the square root of c squared minus a squared. So once we plug in our A and C values, then we get 20. So B is 20. Then we just go through our trig, 6 trig values. Okay, hopefully you still remember. Sine is what opposite over hypotenuse. So it's 21 over 29. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent side. Now our cosecant, secant, and cotangent, if you look, they're the counterpart to because cosecant is 1 over sine, secant is 1 over cosine. So you can see that they're just a reciprocal of the original values, and so is cotangent. Now the next example, we have a point that's on a unit circle. We want to solve for y. Okay, then the y value is going to restrict it with less than 0. All right, so the first thing we know, once again, like before, we know our Pythagorean theorem. In a unit circle, so unit circle hypotenuse equal to 1, so x squared plus y squared equal to 1, right? So when we use this equation, okay, so we try to solve for y, so y is negative, okay? Now, why is it negative? Because we say y is less than 0. If y is greater than 0, then you don't need this negative sign here. Then we take the square root of 1 minus x squared, that's basically from here, right? Try to solve for y, and we plug in an appropriate value for x, then our y is a over 17. Then once we have that, we just use same thing with trig values. Okay, so sine, okay, so sine right here is what? Sine is our right here. So this right here is a y value. The sine of theta is a y value. Cosine of theta is the x value, and the tangent is y over x. So take y divided by x. But once again, y is negative 8 over 17, and divide by negative 15 over 17. You simplify, and you have a over 15. And once you find these three is always easier because they're just a reciprocal of their counterparts. So to simplify trig functions, okay, so when we say simplify, what we want to do is whenever you have anything other than sine and cosine, if you can try to make them into sine and cosine, will be perfect. So for example, secant right here is 1 over cosine. Sine is already sine, that's fine. But cotangent, we can change that to cosine over sine. And once we do some algebra into it, we find out everything cancels out. So the answer is just simply 1. And to solve trig functions, okay, it's just like your algebra, trig equations. It's just like your everyday algebra. You just need to know your unit circle values for your trig functions. So for this particular question, okay, so if you want to solve for theta, then we minus 1 on both sides. So cosine theta equal to negative 1/2. Then you think about your unit circle. Where is cosine? What angle is cosine at? Between 0 to 2 pi in one rotation, that the value of that cosine theta is negative 1/2. So that happens in two places, in 2/3 pi and a 4/3 pi. All right, and then the same thing with this one right here. Okay, once again, we try to get secant all by itself. So we move everything else over, then divide by 3. Now, then again, remember secant, it's hard. Everything we want to do, if we can change to sine and cosine, will be perfect. So if you want to change secant to cosine, we're looking for reciprocal. So once we get reciprocal, we get negative 3 over 2. So again, cosine, if cosine theta equal to, not negative, I'm sorry. If cosine theta equal to radical 3 over 2, then where is cosine on the unit circle? That's a radical 3 over 2. You happen in two different places at the angle pi over 6 and 11 over 6 pi. Now, when it comes to graphing or trig functions, there are a couple things we need to know. Now, the shifting are very similar from previous chapters in our early chapter one. So this C in the back, this number is always going up and down. So there's a vertical shift. And then this A right here is always shifting, horizontal shift going left and right of your graph. Now the only thing you have to worry about is this A and B kind of deal, right? So the B right here, B has something to do with the period of your trig function. So the period, the formula is 2 pi over the absolute value of B. Okay, so if you look at our this example here, here's an example right here. If we have example 3, sine of 2 x parentheses x minus pi over 4 parentheses plus 1. So we know the function you're gonna take original sine function, like you know your basic function again. Your sine function, we're gonna take the function go up 1, and then vertical shift of 1 basically, and going to the right. So you have a horizontal shift going to the right of pi over 4. The period is 2 pi over 2, so it's now pi, right? So your sine period now it's become pi, okay, instead of 2 pi. Then the last one, this 3 right here, is a vertical stretch. So it's gonna, instead of going from 1 to negative 1, it's gonna multiply it by 3. But remember, we have the shifting of 1. So you take pretty much your entire your sine curve, you're going to go up 1. So this new dash line here now, it's going to be your think of it as the original x-axis, right? Okay, then remember our period is now only pi, so every pi we're going to repeat. So if you go from here to here, okay, so you have from here to here, you have one of the pi's. Okay, and then from here to here, you have the second one. So every period is 1 pi. And remember, it stretch up to, so if you start right here, it stretch 3 up. So 1, 2, 3. So it's going to go from 4 to negative 2 now, right? So focusing on this dash line, it's going 3 up, 3 down. That's where the 3 coming from. And we don't forget to shift pi over 4 over. All right, so when you have that, that will give you the base of the graph of this function right here.